Hello. Today we are going to have a short discussion about the difference between CM, classical mechanics, and QM, quantum mechanics. Let us first see what the words mean. Classical mechanics. Classical. What is the meaning of classical? Classical means traditional, which is not modern. So this has been the bedrock of physics since a very long time, about 400 years. Since Newton, the person who is credited for the development and initiation of classical mechanics, Newton, Lagrange later on, Euler, Cauchy, and Hamilton. These physicists, they developed this field of classical mechanics. It was in the 1600s that it was developed. 1600s, 1700s. Later on, a few people added a few things, deleted a few things, and the facts remain the facts. Now, when we know that this is traditional or classical mechanics, there should also be something modern, because this is not modern. So, what exactly is modern? So, modern is quantum mechanics. Let me erase this. Modern is quantum mechanics. Now, we'll first define quantum. What is a quantum? Now, you may have learned something about quantum mechanics, that it applies to small bodies, and it applies to special situations, like people are learning about quantum entanglement and quantum tunneling. So, before we dive deeper, I'd like to mention what quantum truly stands for. Quantum truly stands for a packet. Suppose there is a bulb here. Suppose there is a bulb here, and now it emits, when you turn it on, it emits light. So, early thinkers of quantum mechanics, they thought what light is, or how, like that when you heat an object, such as iron for example, it slowly changes its color towards dull red, and then bright red, and it goes on till it achieves a white color at very high temperatures. Now, light is, according to quantum classical mechanics, light is continuous. That is, it is a wave. You know what is a wave? A wave. Now, Max Planck first initiated this and first put it into use when he defined quantum as a packet. So, energy from this light, it is also called as electromagnetic radiation. Energy from this light, it is not continuous like a wave always. It is actually in packets. The name of the packet carrying the energy is called as photon in this electromagnetic radiation spectrum. It is called a photon. So, photons are emitted from this bulb. Once we get clear of this word quantum, which means a packet, we can further define mechanics. Mechanics is the study of dynamics and kinematics together. Dynamics means something, so the discussion of the motion of the body, which also includes the force which is acting on it. For example, if I take a small car or bus or whatever, if this is moving and I do not take into account what forces are acting on this and causing the bus to move, if none of these forces are taken into account, it is called as kinematics. If forces are taken into account, then it is called dynamics. As you can see, quantum is a packet and mechanics is the sum of kinematics and dynamics. It gives you mechanics. Mechanics is actually a term for kinematics and dynamics together. Quantum mechanics and classical mechanics. Now we'll consider the differences between them. First difference is, I'll write here Cm and then Qm. Classical mechanics, as we have discussed, is deterministic. Deterministic, what does that mean? What is deterministic? Deterministic means if there is a particle and I know its position, let's say the position is x. I know the position and I know the momentum of the particle p, which is equal to mass into velocity. If I know these both, the position of the particle and the momentum of the particle, I can calculate the entire trajectory that the particle will take according to the forces acting on it. Now, it is deterministic. That means I can determine the path of the particle. On the other hand, quantum mechanics is non-deterministic. Small particles like subatomic particles or even particles of very small size, comparable to a few molecules or smaller, quantum mechanics applies very well. It is non-deterministic. You cannot determine the path of the particle because there are some fundamental rules which do not allow you to know the trajectory of the particle. Second, it is governed by few equations. Some of the equations is F equals ma. Force equals mass times acceleration. If in quantum mechanics we want a similar equation, if we know the forces, I can calculate, and forces and mass, I can calculate the acceleration of the object. That is the thing in classical mechanics. Now in quantum mechanics, I cannot do that. So we have something called as a wave function. Gives you an approximate idea of where the body is or where the particle is. Thirdly, it applies to point objects. Classical mechanics applies to point objects, rigid bodies, and regular bodies. What are rigid bodies? Rigid bodies are bodies which, if you take 2 points in the rigid body and whatever force you may apply on it, if the distance between the points is the same, no matter how much the force, then it is called a rigid body. Unfortunately, there is no rigid body in real existence. So in this, we have something called as wave function. It applies to submicroscopic and microscopic regions. Submicroscopic and microscopic regions. It applies, classical mechanics also applies to the bigger bodies. Like as we have mentioned here, if this is submicroscopic, this should be something bigger, like you and me and this chalk holder. These are all they follow the laws of classical mechanics, not quantum mechanics, as an approximation. But in reality, I must tell you that quantum mechanics actually applies everywhere. It is not limited to small particles, submicroscopic or microscopic particles, but rather it applies everywhere. The only problem is it is something like this. Let us say this is quantum mechanics. This is the field of quantum mechanics. Classical mechanics is a subfield of quantum mechanics. Quantum mechanics can explain classical mechanics, but there are a few things which classical mechanics cannot explain adequately, such as the de Broglie wavelength and Heisenberg's uncertainty principle. We'll discuss these in later videos. So actually, classical mechanics is a subfield of quantum mechanics. Quantum mechanics can explain classical mechanics. If you take the equations of quantum mechanics and apply high masses to it, if you substitute masses high enough, it becomes the Newton's law of motion. So therefore, classical mechanics has some drawbacks which quantum mechanics fulfills. This is it for now. We'll continue in later videos. Thank you. Good luck.